Hey everyone, and welcome back. In this module, we'll be covering some of the more real world use case examples of why knowing how to work with C can be incredibly beneficial. And these are going to be things which tend to get overlooked or really don't really get commented on or brought up in the conversation when people are trying to argue for either blueprints or either C. So I just wanted to take out a very small amount of time in this module just to cover some things that may be worth considering if you're, again, still trying to think when or why you might want to bring C into your project. As soon as we've covered this topic, though, we'll be getting back into the Unreal project and we're going to be implementing all of this theory that we've gone through and all of these considerations we've now taken into account. And we're going to start fixing and improving our project. Okay, so we've already seen one of the main benefits, the one which gets spoken about in the most as well, of using C++, and that is, of course, the performance. There is no arguing that C++ will outperform blueprints in most cases, or in pretty much any case. But like I've said, it's always worth considering whether that is going to be relevant. If it's going to cost more development time to implement something in Blueprint, which is really not performance heavy anyway, is it worth spending that extra time doing it in C++? So we're going to take that as a given, but not focus on it too much more. Now, the next thing is looking at the maintenance and the code readability. So this is going to be far more important in a lot of kind of standard use case scenarios. And this is when the project starts getting bigger, when you've got more people working on a code base. Just how easy is it to go through your code, and where does one excel over the other? And again, this is where C++ really does have its benefits. So, as an example, if we take a look just at the very simple project that I've created for the Blueprint versus C++ performance example, a lot of people would argue that looking through just this kind of small section of Blueprint can be much harder at a kind of first glance to get an understanding of what's happening. Maybe not in the difficulty of reading it. This is quite clear what's happening, but the fact we have to then, if we want to see the get total sum function, we have to drop into this, and then we've got things here like extra nodes for truncating the loops to an integer. You've got the pure blueprint function down here, which at a glance may just look like another variable. You then need to wonder what's happening inside of this pure function. And again, you have to keep kind of dropping in and out, going between windows to find what's happening. In comparison, in the C++ alternative, even in this zoomed in presentation mode, this is only taking up one screen of code. If I was using this in the kind of standard resolution that I was coding this in, it's probably only taking up a quarter of the screen then. And you've got both functions all in one screen. It's very clear what's happening. Because C++ has kind of automatically taking the float inputs and is converting those into integers, it means we don't need to see quite as much going on there as well. And in general, it's just a lot easier to see that we're taking enough float. We are adding to this through the length of a for loop. We're calling the function just below called sum, which is taking in the current index of that for loop. And then we're doing something similar inside of the sum function. And this is the sort of thing which becomes really important as the projects are growing. And like I said, as you've got more people working on them, having code which is easy to maintain, update, find things, read through, and so on is going to be one of the really important aspects of your project. And this is again where C++, for the most part, has that kind of win over blueprints. Now, saying that, there are certain things you can do with blueprints, like dropping things into functions, naming things very kind of specifically, and having a good blueprint code base as well. Definitely solves a lot of issues that new developers find with blueprinting. It can be a lot easier to track things in functions, pure functions, and things in blueprints if you're doing that and being very mindful as you go through your project. But generally, Blueprint compared to a C++ implementation, it will almost always be easier to find and read through things in the C++ code. The next thing is going to be for the networking and code replication. So again, Blueprint does provide some or quite a lot of functionality when working with kind of basic networking code. Almost everything can be replicated and set up through Blueprint code. But this is another one of those things where that may have been good. For example, I've worked on projects where that was fine for very small kind of vertical slices to get the concept and the idea across very quickly in blueprints. And all of that was fully replicated, running on dedicated servers, and all of that was fine. We needed one very small bit of C++ to get the dedicated server running, but everything else was done in blueprints. But then again, when it comes to really kind of cleaning up the code and making sure that it is as efficient as possible, because this is kind of where performance comes in. So in general projects, like I've said, a lot of single player stuff, some very basic AI and logic, Blueprint performance isn't going to be very much different, if any, to C++ performance. But when you've got multiple things running on different networks and your servers, that was where putting a lot of this back into the C++ code really gained us a lot of extra flexibility and performance for a lot of the networking code. And this kind of links in, I touched on it just then, to the complex AI as well. If you've got things like RTS games, which will have a lot of more complex AI computation going on, calculations, and kind of the number of units you have are going to be kind of exponential compared to a standard AI in a platforming game or something, then again, having the flexibility and that extra performance from C++ is going to be super useful. And the final couple of things that I find are usually overlooked is going to be things like working with plugins as well. So again, C++ is a great way to export some of your logic for a plugin that you can use between different projects. Also creating things like the plugins for the marketplace, and even working with other technologies and the kind of backends that go into those. So another example is when I was working on a project with Microsoft Mixer, when that was still a thing, that didn't have the best support for Unreal, and we needed to do a little bit of extra work in the backend through some C++ to get the two systems kind of talking to each other properly. So again, knowing a little bit of C++ for that type of thing can be super useful. And if you wanted to know more about creating plugins, there's another course available on the learning platform here, the best practices for creating and using plugins. And again, this goes into the C++ of getting some of these structures and modules ready to go. And then finally, the last thing I wanted to talk about is the flexibility that you get if you need to override or change something in a default class. So Unreal has a bunch of super useful classes, from things like the projectile movement classes, the character classes, and all of that comes with a lot of code which is doing stuff under the hood, which can be super useful. But if you ever find that you need to change something for a project, maybe the way that collision detecting in the character is working just isn't right for your project, but everything else within that class is actually set up perfectly. With a more C++ oriented approach, you can make a copy of that class. Obviously, never recommended to override or change the actual code in the character class and things like that in the engine. But you could make a copy, your own version of that, and start tweaking the code in that C++ version, which doesn't quite work for you. You could also go in and take some very useful information from things like the projectile movement class, see how that's working, rip some of that code out, and again, make your own C++ classes ready for you to override and use in blueprints throughout your project. So these are just some of the topics and examples that came to mind from a lot of the work that I've been doing, and a lot of the things that I just don't see being shared or mentioned online, apart from, of course, the one at the top, which is performance. But it feels as though you almost can't leave that out of a list of benefits of C++. So I just wanted to mention those so that it's something that maybe you will consider in your projects going forward as to why you might want to bring some C++ into your project. As I said, though, moving on to the next section, and in the next module, we'll be looking at the game mode improvements, and we're going to start going through our project and taking everything we've learned up to this point and creating a better balance of Blueprint and C++ so that we can see how quickly it's going to enable us to make changes and updates in the project, whilst also having that flexibility from the parent C++ classes.